Okay, now members, let us see perpendicular and parallel lines. What happens if they talk about those two types of lines? Now, we are going to see that two lines are said to be parallel if they have the same gradient, and these two lines can never meet. Parallel lines can never meet. Now, if they are parallel, their gradient should be equal. So assuming this is the first line and this is the second line. So if these two are parallel, it means that the gradient of this line is equal to the gradient of the second line as we see there. In simple terms, M1 is equal to M2. So parallel lines have equal gradients. That is the some condition they can use to test you in some questions about finding the gradient. Finding the gradient of the line. Let us go through this. Find the gradient of a line parallel to a line with this. So they want us to get a gradient parallel to a line this, but we know if that line is parallel to this, they are having the same gradient. So all we need to do is to get the gradient of this line. And if you compare it with mx plus c, so that our m1 is negative 2. Then the other gradient also is going to be equal to m1, which will be equal to negative. Why? Because if there's another line they want us to get this gradient is parallel to this, it means that the gradients are the same. As simple as that. Then this one, perpendicular lines. Two lines, this and this, meet at 90 degrees. If they meet at 90 degrees, then they are perpendicular. So perpendicular lines always meet at 90 degrees. And you see that this gradient is M1, this gradient is M2. The condition for perpendicular lines, the product of their gradients is equaling to negative 1. So that they are meeting at 90 degrees. This is 90 degrees, so they are perpendicular. The only condition we test if the lines are perpendicular if you show that their gradient, the product of their gradients is negative 1. Let us see this. Show that the lines this and this are perpendicular. What we need to show is the product of their gradients is negative 1. So can you get their gradients? So the solution for the first one, x plus 4. You see them here, if I compare with this, mx plus c, so that here the gradient m1 is 3. When I come to the other line, this one, you see 3y plus x minus 1 equal to 0. I first rearrange this, take x and this the other side, I'll be having 3y, and this crosses the equal sign, so it becomes negative x. And this one crosses the equal sign, so it becomes a positive. Divide through by 3, your y becomes negative x over 3, then plus 1 over 3. So if you compare, start your y equaling mx plus c, that here your m2 is negative 1 over 3. So that's how we can pick that coefficients, negative 1 over 3. So let us see what happens if we get m1 and it's m2. m1 is 3. Our m2 is negative 5. So when I multiply this and this one cancels, I'll be having negative 1. So that our m1, m2 is negative 1, which is the condition. Then you conclude, since m1, m2 is negative 1, then the two lines are perpendicular. The two lines are perpendicular. As simple as that. Then when you come to this, look at this. Find the equation of a line that is perpendicular to this at this point. It means that now the equation we want to find to this line, they are perpendicular at the point to negative 4. In simple terms, they are giving you a line where those two lines, the point where those two lines are intersecting, and always that point is on those two lines. Then this one, they are giving you the equation of the first line, which you are going to use to get a gradient of the line you want to get. In our solution, this 2y, now you first rearrange, plus 1 equal to 0. Take everything the other side, it will be down, this becomes positive, this one becomes negative. Divide through by 2, by 2, by 2, by 2. My y becomes 2x minus a half. So now we can get gradient m1, which is the coefficient of this, which is 2. If you compare. Now is that the line we want to get is perpendicular to this. If it's perpendicular, it means that we can now get gradient 2 because two perpendicular lines, their gradients, the product of their gradients is -1. So you have m1 as 2 divided through my m2 becomes -1/2. Meaning that now the gradient of the second line I want is this. So if I have the gradient and I have a point where that line is passing, because if they're intersecting at this point, it means that this point is on that line also. That's why I'm going to just use my formula. Remember the point I have is 2, -4. This becomes x1, this one becomes y1. And now the equation of a line is given in this form, where x1 and y1, they are two coordinates of a point where that line passes, and this is the line. But I don't really use this method here. If you have this, get the reciprocal of this. To get m2, you get the reciprocal of this and multiply it with -1. The reciprocal of 2 is 1/2 times -1. That's why you will have that. As simple as that. So now, here you see y are the variables. y1 is -4 from here, equaling to m, the gradient of the line we want to find, into x minus the point, the x coordinate, which is 2. Then if you simplify, this will be y plus 5 equaling to negative into, okay, that's open brackets. This negative and this will get x. Then negative and negative, you get plus. Then 1/2 times 2, you get 1. So this will be now, take this inside, we have y equal to -x over 2 plus 1 becomes negative. So our y is -x over 2. Then this will be -4. And that will be the equation. So that's how we handle parallel lines. I wish you well.